Hi guys, it's your guy Olumide, and today we are going to be solving another one of the most commonly asked tech interview questions by top tech companies including Google, Amazon, Netflix, Spotify, Meta, Apple, Microsoft and other top tech companies. The problem topic is K most frequent strings. The problem statement states that find the k most frequently occurring strings in an array and return them sorted by frequency in descending order. So what this place is trying to tell us up to this point is that we are going to be given an array just like how we are given an array here. So and we want to return the k. We are going to be given another value k. So the k most frequently occurring string in the array, so sorted by frequency in the descending order. So and if two strings have the same frequency, we have to sort them in lexicographical order. So now take for instance, look at this string that's given as an array, this array of strings, and this k which is equals to 2. Visually we can tell that go is occurred thrice here, so it has the highest frequency because it occurred thrice, followed by this byte which occur 2 times. So we see that byte occurs 2 times, whereas coding here and interview here occur just once. The coding right here and the interview right here occur just once. So our output is going to be go and byte. Why? Because the problem statement has its divine k as 2, so that is the 2 most frequently occurring string in the array, sorted in their by their frequency in descending order. So go occur first because it has a higher frequency, which is 3, followed by bytes which have a frequency of 2. We see that even in the array they are sorted in the output array, they are sorted by frequency in decreasing order. This one have higher frequency than bytes, so whereas both of them are actually have the highest frequency. They are the 2 most frequently occurring string in the array. So just like in the explanation, the string go and byte appear the most frequently with frequencies of 3 and 2 respectively. So by that explanation, we can say that we have 2 challenges that I want to solve in this problem. The first one is to identify the k most frequent strings. So just here now we know we are able to identify go and byte as the 2 most frequent string, and the second challenge is to sort this string first by their frequency and then lexicographically. So just like here, after obtaining that go and byte are the 2 most frequently occurring string, we have to sort them in decreasing frequency, and even if they have the same frequency, probably like coding and interview that have the same frequency here, we see that we then have to sort it lexicographically, and that means that we have to set it some sort of alphabetically. So for now, let's concentrate on identifying the k most frequent string, and then later we can have time for sorting them lexicographically afterward. But for now, let's first concentrate on how we can identify the k most frequent string in a given array of strings. First, intuitively we have to find a way of keeping track of the frequency of each element or each string in the array, and we can do this using an hash map. So a hash map will do where we have go, this particular first string. Now we see that it has a frequency of 3, so we are going to be having a hash map where the key is the string and the value is the frequency of that string occurrence in the array. So go now is a string in the array, so and it has a frequency of 3, coding have a frequency of 1, byte have a frequency of 2, interview has a frequency of 1. Now the most straightforward approach now is to obtain, we can create an array that will contain the string from this hash map. So and the order at which we insert them, or append them into the array will be based on their frequency. So in such a way that the first k element of the array will be the k most frequently occurring element in the previous array, in the list of string that was given to us, or even in the hash map. What I'm trying to say is that we can obtain an array now that will first contain go right from this hash map, because we know their key value pair now, we know the frequency of each string now. So the string with the highest frequency is what we first put into the array. So we're gonna put go into this array we are building, and then we're gonna put byte next as the second element of the array. Then we can put coding and interview, and then the first k element of the array will represent the k most frequently occurring element in the string of array. So which is that is the first k element in the array will be the answer that we want to return, and that is what you can see here. So right from this array now, we can sort it, and we have we collect it into an array of keys that is sorted based on their value. So we can do that in Python, and I believe in other programming language, whereby we try to sort the hash map in terms of the frequency, in terms of their value. So, and after sorting it, we just convert it into an array, and we get the first an array of their keys. The array is just gonna contain the keys, which is the strings, and we are gonna collect the first key, which is the k most frequent, which is byte and go. But the main inefficiency of this solution that we just spoke about is that it involves sorting all n elements in the string, or I mean all strings, that is all string in the array. We have to sort it at first. So meanwhile, the problem only requires that we sort the first k element in the string of array. So that the problem we discuss, the solution we discuss now will involve that we sort every element. Why? Because we have to go for the hash map and convert and sort all of them based on their frequency, and then convert it into an array. So that way we have to touch every unique element, every unique string in the hash map. So whereas we only need to sort the top k elements, not all of them. So let's see and look at a more efficient way of solving this problem. One useful thing to consider is that if we remove the most frequent string, let's say we remove go now out of the list of string that is given to us in the problem statement, the new most frequent string will be byte, because it now have it now has the highest frequency. So, and that means that when we keep on removing the most frequent string from the list of string, the new most frequent string that we have will be the second one. Then if we remove that one again, it will be the third one appearing like that. And to implement this idea, we are going to be needing a data structure that will grant us access to the most frequently occurring string, or the most frequent string at any time. So such that whenever we get the most frequent string now and we remove it, we can still access the most frequent string again, meaning that after go, if go should go out of the list of strings now, byte will be the most frequent string. So we need a data structure that will allow such, and a maximum heap is actually suitable and ideal for this, because a maximum heap now will allow us to get it's gonna prioritize them based on the frequency, and whenever we try to remove the top element, we can still it's gonna restructure itself, and you can still have access to the next top element in the top frequent string again in the array. So we are gonna be using a maximum heap now to find the top k elements, just like we have in our previous input, this particular input here. So the first thing we'll be doing is that we're gonna be populating the heap. So this is the empty heap now, maximum heap. We are first gonna be populating it. So, and when we populate it, the heap have a way of structuring itself such that the highest frequency will be at the top. And one way to populate the heap is to do it one by one by adding each string into the heap one after the other. And don't forget that to insert, if you look at our introduction, the previous video that talk about the introduction to heap, we have some common heap operation, and one of them is insert. To insert an element into the heap takes log n time, and therefore this means that to insert the whole elements, I mean the whole string, go, bytes, coding and interview into the heap is gonna take n log n. So where n represents the length of the array, I mean the unique string inside the array, right? So but there's a method we can use that I discussed in our previous video, the heapify method. That method is gonna convert a list into a heap, I mean a list of string, something like this format of key value pair, you know, the string and its frequency. So it's gonna insert it into it's gonna convert it into a heap in on time, so instead of on log n time. So we can use heapify to form this heap, and then we will always be assured that at the first at the top of the heap is the string with the highest frequency. So creating the heap like this now, to collect the k most frequent string from the heap, we have to pop. We can just do that by you know, collecting the top element, meaning that popping out of the heap, taking the top element out of the heap k times. You understand? So what I'm trying to say is that fine, we have our heap, and the heap is gonna have a top element now based on the frequency, and when we pop the first time, we can pop and add to our results list. Don't forget the problem statement asks us to return the result. It asks us to return a result, which is the list of string in terms of their with the highest frequency, in terms of their decreasing frequency. So and we are sure that at the top of the, you know, we are using a maximum heap, so at the top of the heap is gonna be the string with the highest frequency. So popping out of and, you know, removing that top element from the heap, we are gonna add it to the results, and now we are sure that the heap is gonna restructure itself, and the next most frequent string is gonna be at the top of the heap. We just have to do it again the second time. So basically we have to do it k times, so that we keep removing the top element from the heap. So this way we have go and we have byte, and now coding will be at the top again, because it's, you know, the heap is gonna restructure itself, and we just have to return go and byte. We don't really have to perform the heap 3 times. We only have to do it k number of times, knowing fully well that each time is gonna give us the element with the top I mean the string that occurs most with the highest frequency. Now let's consider a situation whereby the two string has the same frequency, just like coding and interview that have the same frequency of 1. We need to ensure that in that case the one that comes first lexicographically, mean that in this case now C in the alphabet comes before I, right? So therefore C is gonna have high priority than I. So we are just gonna ensure we have that. So in case if they have the same frequency, C will come more than I. So, and because of that, we are gonna be, you know, to ensure that we're gonna be creating a custom comparator for the heap that will prioritize string lexicologically when their frequency match. So what this means is that in a situation whereby their frequency, you're gonna create a class. So don't forget, we'll be using a class, I mean in the code implementation now. So, and we are gonna write the code such that whenever the frequency is the same, don't forget that they appear a string and its frequency. So whenever the frequency of the string is the same, then we want to prioritize them lexicographically. So you're gonna understand this better in the code implementation. So let's move into the code implementation now. In the code implementation now, for the k most frequent string, we are gonna be creating a class pair. Why we are creating this class is because if we look at the logic, we can see that in effectively and efficiently solving this problem, we need a key value pair, something like a pair of the string and its frequency. The string, look now, so that way we can, it can make sense to the heap when we have the string and the frequency, so we can it can identify that, okay, fine, this particular string have the highest frequency, and we can add it to the top of the heap. And as well, whenever we are about to remove that particular top string, we can easily get the string from it and add it to the results that we want to return. So, and that means we need a more flexible object, and that's why we'll be using the a pair, the class pair. So that class, we're going to be initializing the string and their corresponding frequency. So, and that way we can easily access both string and the frequency, and we can easily do the comparison. So that's why we're defining the class particularly. So now in the initialization for the class, we will pass in self the string and the frequency. So this class object represents, instance of the string and their frequency. So self dot string equals to string, and self dot, so this is the frequency of each string. Frequency equals to frequency. So then we are going to define the operator, the comparison operator, which is less than operator. So while they are using this, they have to call it something, so it's automatically called. So, and that's why we are using it. We don't have to, we can just easily call it using the less than and equals to sign without having to call a method. So right now it's also going to have itself and others. Why we are passing order is because we are going to be comparing this a particular instance of pair with another instance. So the instance itself, while the other instance is represented by order. So, and then we want to first check if their frequency are the same. If the frequency is equals to if it's equals to order dot, that is the order pair objects, frequency, string dot frequency equals to order dot frequency, we want to return, so all this less than and greater than is a true, it's gonna return true or false. So if we say this is less than this, is that true or false? So we want to return, in this case, self dot string is less than order dot string. So, but in a situation whereby they are not equal, whereby their frequency are not equal, we want to return self dot frequency is greater than order dot frequency. So this is what we are returning in this case, and what it means is that what this place actually means is that in a situation whereby their frequency is the same, look at the coding and interview string in our visual example in the problem statement, we see that they have both have a frequency of 1, and because of that we want to compare them lexicologically, and that's why we are comparing their string to each other. So if the string of one object is A and the string of another object is C, or starts with A and C respectively, like that, so definitely A is less than C because A comes before C. So A is less than C. So but in a situation, and therefore if it is A compared with C, it's gonna return true because A is less than C. But in a situation whereby we are dealing with frequency like this, that is whereby their frequency is not the same, Go has a frequency that is greater than that of bytes or that of coding, so it's gonna return true. So that's what that piece is trying to imply. So after defining the class, let's go into the function itself. Let's go into the function. I'm gonna call it the k most frequent string, and it's gonna take in strings, which is a string object, sorry, is a list of string. right, a list of string, and we're also taking the k, which is an integer. So, and we'll be returning a list of strings. Don't forget, we'll be returning a list of string. Because the problem statement asks us to return the k most frequent string. So right now we are going to define a variable called frequencies. So we are going to be using the counter method. So let's import it first. So it's a method that will help us convert something like string into a, it will count their frequency and convert it into a hash map. So from collections import counter. So we use it to count each unique character in the string, each unique string in the list. So we say counter of strs. So now that we have this, counter will be a key value pair, right? And now we want to collect pairs. We'll be creating a pair function now, and we will say a pair. We'll be calling the pair class, and we'll be calling it on string and their frequency. For you just I'm gonna explain it. For string comma frequency in frequency dot items. So what I did here is that I try to convert each unique string in the in our strs. So in our strs string, let me write that strs down so you can see it. So this is the strs. So each unique string, first of all, they are counted. So how many times does go occur 3, how many times does byte occur 2, how many times does, so that's what this counter does. And now it returns a hash map. So I'm now iterating through the items, that is each key value pair. I'm collecting them as string and frequency, and I'm now using them each string and frequency to create a pair object. So don't forget, we have defined the pair class now, and that way we can, for each pair object, we can access their string attribute and their frequency attribute. They also have this comparison operator that the heap is going to need. So right now let's also import our heap. Import heap q. Right, so I think this is how to import the heap. So now that we have this pair, what we want to do is that we want to convert this list of this is a list of class object, of peer objects or peer instances. So we want to convert it into a heap, and like I told you, we can use the heap q. So let me say string, let's call it the string heap. The string heap equals to heapify. You can use the heapify method, heap q dot heapify. So, and we just have to pass in the PS to it. So let's call it our heap. In fact, let's call it our heap. So it's gonna convert it into a heap like that. So using heapq.heapify PS. So now that we have our heap, everything will be handled for us. Based on this comparison operator that we defined there, it's gonna place it at maximum heap. So it's gonna place the top element at the top. It's gonna structure it well. So, and all we just need to do is to return a list of will I say heap q dot heap pop. So this way we're gonna be actually, like I explained the logic, well, heap is gonna handle the whole ordering for us. So all we just need to do is to pop out of the heap k number of times. So if q.heap pop, we just have to pop out of that heap object. So for k number of time, range of k. So this is how it's just easy like this, because everything is sorted. When we make everything is sorted, so when we make the first pop out of the heap itself is going to restructure itself. So it's going to restructure and replace the top element. When we perform that pop out of the heap, it's going to get us the top frequency string at the top of the heap, and doing that is gonna restructure itself and place another string at the top of the heap. So it's like it's so efficient in doing things like that, and that's why we are using it. So this will just return this, and we are done with it, because we have converted into the heap fine, and then we have iterated through the heap k number of times to remove the k most frequent string. So print this, and we pass in our strings to it. So now let's run the code. Right, sorry, there are two things we forgot here. When we are calling the function, we have to pass in a k to it, right? We have to pass in k, which is talking about the frequency and the number of the frequent string that I want to return. So I forgot to add that, so I'm adding it now. And one thing again that we should do is this particular, don't forget that our heap contain class. You don't forget, when we are this is a pair that contain a list of class object pairs. So we convert that list into a heap. So literally inside our heap is just consisting of pairs of classes. So whenever we are trying to pop out of the heap, is also gonna pop out classes for us. So we have to apply this strn method so that it can get us the string attribute of that class that we are popping out, right? So and now we can call the function again. Let's run the code again. Alright, I found out that there is a minor mistake right here. q.epify is actually a how would I call it? It doesn't return. It doesn't have a return. It's just a method that we use just like that. So rather than doing this, we can just call this our heap instead of ps. So and we can just call q.epify on our heap, so without expecting anything to be returned. So it's an in place, it's gonna make an in place changes to the heap. So it's not really gonna create a new heap object, it's just gonna make in place changes and convert this list into a heap in place. So so sorry for that. And after performing q.epify right, we can just move on and let's run the code again. So I hope you understand. What I did there is that instead of saying assigning a value to q.epify, so we should not assign a value. It makes in place changes. So we should not assign a value to it. So it's gonna change heap in place. So and now we can see it returns go and byte, which is the two most frequent string. So I hope you learned from the mistakes and the corrections in this. I also learned from it, and I'm glad these things occur. So because it gave us a more knowledge about what it really is. So thank you so much for watching this video and following me all along through the errors and corrections. So thank you, and don't forget to like. Don't just ignore it because of the mistakes that we made. I'm actually gonna leave it unedited, so I want you to subscribe for more and to follow me as well. I'm on LinkedIn, on YouTube, on TikTok, on Facebook. So and wherever you are watching this, just follow me, subscribe, and expect more problems is gonna be solved in my subsequent videos. So thank you and stay blessed.